Ever feel like your data is just scattered everywhere? You've got customer info over here and order details way over there. Well, in this explainer, we're going to unlock the single most powerful tool for bringing it all together, the SQL join. Let's dive in. So here's our game plan. We'll start by figuring out why data is split up in the first place. Then we'll look at the messy, brute force way to combine it before we discover the really elegant solutions. We'll find perfect matches, see what happens to the data that gets left out, and even learn how to stack data vertically. By the end, you're going to have a new data superpower. So why not just keep everything in one giant spreadsheet? Well, in good database design, you actually split related info into different tables on purpose. It's a thing called normalization, and it's all about avoiding repetition and keeping your data clean, efficient, and way easier to manage. Okay, so here's our first piece of the puzzle, a student's table. Pretty simple, right? We've got a student ID and a last name. But check out that last column, faculty ID. It's just a number. It doesn't tell us the faculty's name. It's really just a key that points somewhere else. And this is that somewhere else. Our second table, faculties, is what connects that faculty ID to an actual name, like computer science or economics. This is just smart design. Think about it. If a faculty changes its name, you only have to update it in this one spot, not for every single student. So here's the big question. How do we bridge this gap? How do we take the last name from one table and the faculty name from the other and put them together in one clean, useful list? This, right here, is the exact problem that joins were born to solve. Now, before we get to the slick solution, let's look at the computer's first, most basic instinct when you ask it to combine two tables. You can think of it as just throwing everything at the wall to see what sticks. It's called a Cartesian product, and trust me, it gets messy. The main thing to get here is that a Cartesian product doesn't use any logic at all. It just takes every single row from the first table and pairs it up with every single row from the second table. So, if you have 2 students and 3 faculties, you don't get 3 neat rows, you get 2 times 3, which is 6 rows of every possible crazy combination. And this is the result of that chaos. I mean, look at this table. We have Petrenko listed with computer science, economics, and law. The same goes for even Anko. Most of this data is completely wrong. It's logically meaningless. It's just noise. We need a way to filter this down to only the combinations that actually make sense. And that brings us to the hero of our story, the inner join. Think of it as the intelligent filter that sifts through that messy pile we just made and pulls out only the pairs that are a perfect match. The concept is really simple but super powerful. An inner join looks at the linking column in both tables, in our case faculty ID, and it only keeps the rows where those IDs are identical. It's looking for the intersection, the data that exists and is related in both sets. And here's how you build it. The structure is pretty much always the same. First, you select the columns you want to see. Second, you start from your first table. Third, you inner join your second table. And fourth, this is the most critical part, you tell it on what condition to match them. In our case, we're students.facultyid equals faculties.facultyid. And voila, a clean, logical, and correct table. Petrenko and Sidorenko are correctly matched with computer science. Ivanenko with economics. Perfect. But wait a second, who's missing? Take a look. Student Kovalchuk, who had no faculty ID, he's gone. And the law faculty, which has no students, is also gone. Yeah, inner join only cares about those perfect matches. So that brings us to our next big question. What if we want to see the outsiders? What if our whole goal is to find those students who don't have a faculty assigned yet, or maybe faculties that are empty? For that, we're going to need a different kind of join. The key difference is actually pretty simple. While an inner join gives you just the intersection, that middle part of the Venn diagram, an outer join gives you the intersection plus the leftovers from one or even both tables. It's designed specifically to show you what doesn't have a match. Let's start with a left join. The rule is simple. Whichever table you list first, the one on the left of the join keyword, is the priority. A left join basically says, hey, give me every single row from this first table no matter what. If you find a match in the second table, awesome, bring it along. If not, just put a null or a blank in that spot. And look at the result. Because we started with the students table as our left table, everyone is here. Petrenko, Ivanenko, Sidorenko, and there he is, Kovalchuk. Since he didn't have a matching faculty, the faculty underscore name is just null. This is incredibly useful for finding things like, say, customers who haven't placed an order yet.
Now, you can probably guess what's coming. A right join is the exact opposite. It prioritizes the second table you list, the one on the right. It says, give me every single row from this second table, and if you find a match on the left, bring it over. If not, just fill the blank with null.
So this time, our faculties table was on the right, so every faculty is guaranteed to be in the result. And there it is, the law faculty. Since no students are assigned to it, the last name column is null. This is perfect for finding things like products that have never been sold, or in this case, faculties that don't have any students.
Okay, let's switch gears completely. So far, everything we've done has been about adding columns from one table to another, combining things horizontally, side by side. But what if you need to do the opposite? What if you need to stack rows from one table right on top of another?
This is the big conceptual shift. Forget adding columns next to each other. We're now talking about taking two separate lists, maybe a list of current students and a list of alumni, and combining them into one single long list. For this, we use something called the union operator. Now, there are two flavors of this. First, you have union. It's smart, but a little slower. It combines the lists and then does extra work to find and get rid of any identical duplicate rows. Then you have union all. It's dumb, but it's fast. It just takes all the rows from the first list and slaps all the rows from the second list right underneath, duplicates and all. If you know you don't have duplicates or you just don't care, union all is always going to be the faster choice. So, let's bring it all home. We started with scattered data and a simple question, and now you have a powerful set of tools to find the answers. You've officially learned the language of how data relates to itself.
Here's your cheat sheet. Use an inner join when you only want the data that perfectly lines up. Use a left join to find things in your main table that are missing a connection. Use a right join for the reverse. And when you need to stack lists, use union for a clean, unique result, and union all for raw speed.
At the end of the day, joining data isn't just a technical exercise. It's about asking deeper questions. It's about uncovering relationships, finding the exceptions, and telling the complete story. You have the keys now. So what hidden stories is your data waiting to reveal?